So for piecewise functions, a lot of times what's going to happen is you're going to get a question like, find the value of c that makes the function continuous. So in other words, we got to figure out what number here will ensure that this graph is continuous, meaning no breaks. Remember the definition of continuity we talked about. The limit from the left and right have to be the same, and they have to be equal to the function value. So that's going to give us a pretty good hint as to how to solve this one. So in order for that to be true, these two pieces have to essentially be equal to each other. I'm going to show you a graph once we finish, and you'll see exactly how it works. But only one c value is going to make that true. So if you get a question like this, the first thing you're going to do is set the pieces equal to each other. So I set the top piece equal to the bottom piece. This one is a little bit more difficult. Does anybody know how to solve this from here? I was helping somebody yesterday with this. I'll give you a hint. You don't just take the square root of both sides. You have to do something else. Starts with the letter F. You have to factor. Why? Because this is a power of 2, and this is a power of 1. And there's really no other way to do it. Okay? Actually, you know what? This one is simpler than that because of this number right here. All right, so you know what? We don't actually have to go through all that work because they both meet at 3. So for step 2, we can actually just plug in that value. Whatever that value is that they have in common, we can just plug it in. Because we already know at x equals 3, they have to be equal to each other or else it wouldn't be continuous. We're going to plug in that value. And now all we have to do is just solve for c. So we get 3 squared, which is 9, and 4 times 3, which is 12. Then get all the c's on one side and all the numbers on the other. So I would add c to both sides like this, and then get the 12 to the other side, so I'm going to have to subtract it from both sides. And I'll go back in a second so you guys can get this copied. I just want to get through this example. Then you would divide both sides by 3, and you're going to get c is equal to -1. So let's take a look at the graph of this. Obviously, it's going to depend on the value of c. So we're basically going to graph x squared minus c, 4x plus 2c. Now, this particular point, c is equal to 0. We can see the graph isn't connected. If we make c bigger, they're going to spread further apart. But watch what happens when c becomes -1. They end up touching and they end up being continuous, no break in the graph. Okay? So when c equals -1, the piecewise function becomes continuous. Any other c value and it's not continuous, there's going to be a break. All right, let's do one more piecewise function. This involves natural log. I don't know how good you guys are with that. Natural log means, and you've got calculators, so it's not going to be terribly hard, but natural log means log base e. Okay, logarithm is the reverse of exponents. In other words, let's say we had a function 2 to the x, so 2 raised to the x power. The inverse of that would be log base 2 of x. Anyways, just like last example, we're going to find a value of c that makes the function continuous. In other words, these two pieces of the graph come together for this particular c value. Okay? If y'all want to, you can just watch because, like I said, you know, but the steps are the same. We're going to set them equal to each other. And then simply, for step 2, like before, we can just plug in where these two pieces meet, which is at x equals e. Yes. So I'm going to plug in e for x, just like this. E is a number like pi. If you plug into your calculator and hit enter, it's going to say 2.718 something something something. And just like with pi, if you plug it in, you get 3.14159, bunch of decimals after. Where it comes from is the way I always think about it is it's used in compound interest. If you're investing money or borrowing money. Okay, first thing I notice is this right here. It's an inverse property, e to the natural log of whatever. That's just going to give you 9 back. And then this right here, you can move the 3 to the front. It's going to end up being 3 times 1, which is just 3. Okay? Again, I'm probably not going to test you on this because if you guys haven't learned logs, I can't really, it's a whole nother lesson, okay? But anyway, when you have e to the natural log of something, it just becomes whatever's inside. So that's going to give you 9 back, okay? Which becomes 9c. Now it's just a linear equation. Can add 1 to both sides. And then next thing we're going to do is subtract c. I'll go back to this in a second. So we get 4 equals 8c, c equals 0.5. Now let's take a look at what this one looks like. All right, here's the 2 pieces, and here we have c equals 0. In order to make the function continuous, if I move c up to 0.5, they connect. Okay, notice any other c value, those 2 pieces of the piecewise function will not connect. Only at c equals 0.5. We can see how it changes down here, make the function true. And like you can see here, e is equal to approximately 2.718. Okay, but at some point we will have to review logarithms. I can teach you guys exactly how to do them. For right now, I think on the worksheet, the piecewise functions that you'll be given are just polynomials.